7 and 12. I'll do 7 first since it's on the front. Let's see, 1/5 to the u squared plus 8 equals 125.
What?
I said, that's not the right page? Oh, great. Moogly. Okay, hold on, let me get the right. Log 5, 3k plus 12. Okay. My bad. Very first thing I see is the log 5 before I even start. But remember, you want to condense down. Does everybody agree with that? You could, if you want to. Is that the way y'all did it? Well, I'll do it the way y'all did it. There's not one particular way that you have to. It's kind of like properties of exponents. As long as you do things that are legal each time, you can do different orders. So y'all divided here first? All right. Log base 5, 3k plus 12 equals 3/4 log base 5 plus 4, 5 divided by 5, 81. Did you bring the 3/4 around? What is the 4th root of 81? 3, and then 3 to the 3rd is 27. Now, because both logs are the same with the same base, and that's all that's on both sides, I can eliminate those and just set the arguments equal. So 3k equals 115, and k is, and it works. You plugged it back in. Show me what are you talking about? Yes. Show me one that does that. Show me one that you do. So if you had like, you mean like this? So 2 to the 5th equals x. 2, 4, 8, 16, 32. And so to check it, I would have to say, well, does log base 2 of 32 equal 5? And when you put this in your calculator, you need to do log 32 divided by log 2. And it might be that you have to do this when you put it in your calculator. I think that was happening to Robert yesterday, if I remember correctly. Oh, if you ever end up with a negative number here, it's an extraneous solution. Right. Like if you end up with like 2 log base 5 of -3, bless you. Even though when you bring that around, it would work, it has to work from every aspect, because this is the same as doing this, and I can't evaluate that with a negative argument there. So this would be extraneous. If you ever have a negative number with the log there, yes, none. Yeah, extraneous. Right. You said 5, Cameron? Yeah. 1/4 natural log 16q8. Your trick to these is being able to condense them before you start. The better you are at condensing and getting it worked down to something simpler, the easier it'll be to solve it. Here, I'm going to bring this exponent around. Make sure when you do that, though, this exponent, because this is in parentheses, it's going to the 16 and the q, not just the q. So 16 to the 1/4, what times itself 4 times gives you 16? 2. And then if I've got a 1/4 here, a 4th times 8 is 2 again. Minus log 3 equals log 24. Again, I want to condense it down as much as I can. So I'm going to divide. So I have log of 2q squared over 3 equals log 24. Now they're the same, right? So since they're the same, I can just set the arguments equal. 2q squared over 3 equals 24. And how do you solve that? Multiply the 3. 72. Q squared is 36. So what is Q? Plus or minus 6. Now's where I'm going to have my extraneous solution, but I have to check. So I need to check the 6 and I need to check the negative 6. Oh. It depends on where your Q is. No, I think both of these are going to be real solutions. Both of them were. So look back at your original equation, right? So because I'm raising this one to a power first, because that was in the original equation, not that I'm having to move it over here, but because it's, okay, this might be easier for you to do then. If this is easier, try this. In your y equals, well, no, because then you're going to have to do change of x. That's not going to be easier for you. Without doing any type of manipulation, any type of anything, if you plug it in and you get a negative number there, then it doesn't work. But here, because whenever I plug it in here, it's raised to the 8th power already. That's without me doing any, you see what I'm saying? So if this was just log of 16q, the negative 6 would be extraneous. Because 16 times negative 6 is a negative number. And that would put me negative here, which would put me extraneous. Even still. Or even if there was a 2 in front. Even still. Even though after you do that. Well, I mean, it depends. Yeah. All right, are we good on the front page before we flip over? Okay, back page. Number 12 and 15 is what I've heard. Number 12. 1/2 log base 27 5c plus 6 equals 2/3. I'm going to bring that exponent around here. So I have log base 27 5c plus 6 1/2. And I'm just going to change the form because I just have one log. Remember, if you ever have one log, just one log, you isolate it and then change the form. E it. That's right. What's your base? 27 to the 2/3 equals what's 27 to the 2/3? Yeah, you do. What's the 9? Because the third root of 27 is 3, and then 3 squared is 9. You did not just guess that. Remember, the goal is to solve for C here, so now what do I do? Do the 1/2. That's fine. How'd you get rid of the square root? How do you get rid of a square root, y'all? Square both sides. Same thing if it's a 1/2 exponent. Remember, whatever this fraction is, you raise both sides to the reciprocal of that to get rid of it. So, right? If it had been 2/3, I'd raise it to the 3/2. Yep. Because what? Remember, a power to a power multiplies, right? So what's a half times 2? 1. So now I have 5c plus 6 to the 1, which is just 5c plus 6. What?
Yeah, I did 4/3.
Oh, you can do that. Move the 6. I have 75 equals 5c, so c equals what? So, how do you check the extraneous? Go back to the beginning. Okay, so 15. I'm putting a 15 in right here. That's the very first equation, right? So 1/2 log base 27, 15 times 5 plus 6, does it equal 2/3? But what? Y'all are doing so much better. Is 27 to the 2/3 power equal to 9? Yes.
I wouldn't be able to do that, but I could. Yeah.
Huh? What? Oh, yeah. Yeah. On what, 10? We can do that. Yeah. Yes. 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 No. So if you do e to the second power equals 4u, there's literally an e button on your calculator. Are you talking about whenever you check for extraneous, or you talk? Oh, yes. When you check for extraneous, you're ln. You put it back into the log. Yes. And those aren't going to be exact because you're going to have rounding issues because e is irrational. You're going to have to round it somewhere. Right. Should be really close. Should be close to 5. Unless, well, it depends. If you add the 3 to it, then it should be close to 5. But if you don't, or subtract 3, right. It depends on where you put it in. If you plug your solution in here, so you would have log of, what'd you get for you? What is it? 1.84. You put all of that in your calculator and it should be close to 5. Again, it's not going to be exact because you've rounded. 1.84 is rounded, so it won't be exact for you. Number 10. 2 log base 2 3x minus 7 equals 10. The only thing I will tell you to caution, Mac, if you do that is because you might have a real solution that's the negative of the square root. You know what I'm saying? So whenever I change the form on this, it's 2 to the 10th equals 3x minus 7 squared. When I take the square root here, I get a plus or a minus, right? Oh, never mind. You'll still get it.
Wait, why don't we do all that now?
No.
Why did you do all that? I did not do that.
What'd you do?
I didn't.
You can't distribute the 2.
But no, I didn't do that.
You did.
I multiplied by 1/2.
You did that. Oops.
I did 9x squared minus 45.
I really did it wrong. Wait, did I have multiplied it the 2 by 1/2 and then the?
Yeah, I did not.
Yes, you can. That's fine. That's fine. You're gonna still get the primary root. You'll be fine. Yeah, right. So if you isolate the log first, remember I told you you can isolate the log first? I don't know if y'all wrote that because y'all were just going by the guided notes that were on there. You can start this way. This is what Mac was saying. And I think you were saying it too, James. You were just saying by half. And now you can do 2 to the 5th equals 3x minus 7, which is going to be the same thing I get over here because this is 1/2, right? The square root of 2 to the 10th. 2 to the 5th. Right? Are y'all following me? Carter, what the heck? Right. And then 32 plus 7, that's right. Look at you go. $16? Why do you have what?
1,000.
I don't know. Why do you have that? Why are you laughing at him? I think you did it the wrong way, Robert. Which part are you? Where did you get the wrong?
Oh yeah, that is a mark. Oh, so technically I can't get the right answer. What was your final answer?
You did 2 to the 10th.
No, I
You
did this right. Wait, what was the final answer? Yeah, it was just wrong. Yeah.
13.
Where that? Yeah.
All right. Y'all both did that? Y'all both did that? Oh my goodness, y'all. All right. Which other one did y'all say? 16. Jackson was wrong. No, you didn't. Y'all all did that. Oh, I give up. I give up. All right, 16. I missed something there because y'all got deadly quiet after Carter says, whoa. Not surprised. All right, let's condense. Log base 12. This is multiply, right? 4n squared to the 1/2 is going to become 2n. So I'll have n plus 4 times 2n, 14, equals 2. Distribute that a little bit. And change the form. What did you get for this one, Carter? I'm going to divide everybody by 2 first. 72. Yeah, I may equal 0 since it was a quadratic. Yep.
Oh my gosh, I did it. No, Carter, we did the same thing. I did it right. Wait, it's not right.
Yes.
No,
You'll just have an extra step in solving, but you should still get the same 2 answers. Yeah. You got 3 answers? I think the 0 is the one that's messing you up. So when you have the 2 on the outside like that, that is never going to be 0, so you drop it off. The only time that becomes 0 is when there's a variable hooked with it out there. What multiplies to negative 72 but adds to 14? 16 and 2? I don't know.
Yeah. Wait, that's not.
That's not right.
Doesn't
18 and 4.
I'm listening to y'all.
Negative 18 and 4.
No, he is not. It's what? 18 and 4.
18 and negative.
So negative 18, I'm guessing that negative 18 is the extraneous solution. Well, if you go to plug back in, like if I plug in negative 18 here, negative 18 plus 14 is a negative. So yeah, that's extraneous. Negative 18 is extraneous. Right. It's not yes, no. No, it's not. How is it?
It is. Yes, it's extraneous, and it's not an answer. No, it's not extraneous, but it is.
Whatever, bro. Okay, what else? All right, so if you divided by 2 on both sides first, is that what you did? That's what you did for every other one like this, but you didn't. Are you sure? How'd you get 2 answers if that's what you did? Squared. Which is 1 equals 4a squared minus 4a plus 1.
Yeah, okay. So this contradicts what I did earlier, but well, I didn't just figure it out.
So at this point, you did square root. So you got 2a minus 1 equals plus or minus 1. So then 2a equals 2 or 2a equals 0. So a equals 1 or a equals 0. Are you saying how does it match up to this one over here? Yeah, it does. You got to pick the extraneous one. If I plug in 0, it works. Sure it does. 0, oh no it doesn't. You're right. That one's extraneous. I did it 2 different ways. But, okay. One plus 1 is 2. Yeah. What else? Well, more, so a little bit harder with the log equations. 15? No, we're not under that. We're going to solve exponentials using logs, but we're going to have to do logarithmic. I'll show you. If we can ever get to what we still haven't made it to, we're not to where I picked up starting pre-cal last year. Yeah. We haven't even got the trig stuff yet. No, don't say that. That's not true. We'll get there next unit, and we do a unit circle project, but I mean, I don't have any made because I've not done, I had to back up and punt. That's why now we're running. All right, log base 2w squared. No, is this for you? Oh, Robert. Just refer to yourself and. Man, just shut up. We'll change the form. I'm going to E it. Multiply by W plus 3. So this is. Make it equal 0. 2w squared minus 8w minus 24. I divided everybody by 2. Multiplies to negative 12, adds to negative 4, negative 6 and 2. Negative 6, 2. Do you see?
I did like the big factor.
The big, oh, you didn't take the 2 out first. You didn't take the 2 out first. Oh. Oh, that's fine. You can still do that. That's fine. So, Carter, if that leading coefficient's 1, well, but I divided everybody by 2 to make it easier to factor.
I will be back here at 1 o'clock.
Carter, hi.
No, actually, no.
Ready?
Exponential equations, take 2. All right, so your other exponential equations, we did base manipulation, right? We tried to get the bases the same, drop them off, set the exponents equal, but what happens if that doesn't work? So 2 scenarios. Scenario 1's not written on your sheet, but I don't think that it's necessary to make this any harder than what it is. So if you only have one exponential piece or one exponential term, so like 1 through 8. Look at 1 through 8. 1 through 8 all just have one exponential term. But whenever you hit 9, you see how you got more than one exponential term there? Okay, so I just want you to see the difference in what happens. No, 7 and 8 only has one exponential term. See, negative 2 times 4 to the 2x plus 7 plus 9 equals negative 55. This is an exponential term. There's only one of them. Okay. All right. When that's the case, all you want to do is just like with the logs, you want to isolate. There is. There is. Like there's even like motion detectors and stuff because the lights are off when I get here in the mornings, and then as soon as I walk in, the first one to walk in turns the lights off. They turn on upstairs. All right.
Because we could stay and hide after school all the way until like everyone's gone.
I know, y'all got a long time. All right. Isolate the exponential term, change the form, change the form, and then solve. So I'm just going to do number 8. These are the easiest. These are the easiest, and it will save us some time for the little bit harder ones. So look at number 8. I have -2 times 4 to the 2x plus 7 plus 9 equals -5. So my goal is to get this portion completely isolated, all by itself. What? Once that's completely isolated, then I can change forms and solve. So how am I going to get what's circled in red by itself? What do I do first? Before that, subtract 9. Okay, I'm going to move the 9 first. I'm solving, so I need to go stab map, right? I need to move the 9. When you solve an equation, you go... Explain it, Carter. When you simplify, you go PEMDAS. But when you solve, you go backwards PEMDAS. So you go stab map. So I'd add or subtract first. And then divide by -2. All right, 4 to the 2x plus 7 equals 32. Now that it's completely isolated, I can change the form. So log, what's the base? Of equals. There you go. And then you solve it. This is a number. If it's not an exact number, put it on your calculator. So do log 32 divided by log 4. If you have the base thing, do the base thing. How? How?
What are you gonna do with the log? How are you gonna solve that?
There's not a log.
It's right there.
What?
Oh, he's saying you could solve the 4 2x plus 7.
You can solve that? Do it. Go. Mark that go. I can. That's what I'm doing with the log. All right, look. Log.
Oh wait, are you changing it back into the form?
Robert, let me ask you this. How can you solve that for x?
I forgot, but I knew.
And let me not even make it 16 because I don't want it to be exact.
Oh, yeah. You can.
Oh wait, but that was just have a, you were just
Right, well, that's what I'm saying. So that's what I just did. You were acting like you didn't understand why. All right, what's log base 4 of 32?
wait, can you change the form to the form?
5 over 2.
Okay.
So you're going to give us like that.
Yes.
Wait.
I just solved it.
You have to plug in log 4. Wait, so your calculator doesn't have to change. Wait, you can change it. You gotta change. No, wait, found it.
God, how much money has been currently spent on that?
Nobody else thinks that things like that are funny, but you just
Okay, so how do you,
Carter, shut up.
yeah, correct. So how do you do it? How do you calculate it?
Okay, so you're gonna do log 32 divided by log 4. Okay. Now I got 2.5, so now I subtract 7. What's 2.5 minus 7?
So we have to do the first part one more.
Dude, I got it, bro.
And now
-9/4. I don't know where you got.
Ooh, this is not going well. Okay, what?
That's what I got. Yeah, that's it. We're done.
No, I don't even know where you got.
Should we make it into
If you'd like.
Oh, did you subtract the 7?
Yes. Is that where I lost you here?
I think I can do all of them.
Really hard.
1 through 8.
Alright.
That's what you probably wouldn't have any trouble doing. No. Now, a couple of hints before I move on to the hard stuff. One's like number 7. If you need to get rid of a fraction, don't ever divide by a fraction. There you go. Multiply by the reciprocal.
Wait, you can just do that?
Yeah.
I don't understand.
And then
Subtraction by the line number, how you got neither.
Well, okay.
Yeah, you would multiply.
So what is it, negative 6?
What do I do first?
Add the 1.
Add the 1.
And then you would
multiply by 3/2
Hold
by
on,
3
hold on.
halves?
So I'm going to multiply, instead of dividing by 2/3, I'm going to multiply by 3 halves.
Multiply by the
What's 21 times 3?
All right, now you
Now it doesn't make, oh, there you go, Robert. You can get a negative number over there. But what do you mean? Okay, so what is log base 2 of 63? And you added 6. You should. Right now, let's just solve them tonight because that's where we got hung up yesterday. Let's just solve them tonight. Yeah.
Oh, after I add the 6.
Oh,
Oh, wait, that's the answer.
Okay.
Okay. 9 through 12 are harder. They're hard. All right.
Like they're hard for me.
they're not that hard.
They're hard work was.
Which one?
2 9.
Yeah, you don't do the easy one.
Yeah, they don't even look hard.
Here's what we have to do. More than one exponential term, we're going to log both sides. No, we didn't do this.
Log both sides.
No.
How are you gonna log it though? How do you log it?
How are we going to log it? So let's look. We've got 2x plus 5, 3x minus 2. I can't just change forms, right? I mean, because then I've got more exponents and everything. I guess you could.
Just do the
Yeah. Yeah, that's what I said. We did that.
Yeah, no, that's not one. How am I going to get the bases the same?
Make them log.
What?
Make them log.
No, the log is basically the same.
Why? If I do it to both sides, I can't do it?
Oh, that's
10?
yeah, that's actually. Why are you
Because I want y'all to try to figure out if I'm trying to give you a little bump in the right direction. This is brand new. We didn't do this even in Algebra 2. Can you do what we did yesterday here? So what are you going to do? Yeah, but if you drop them off now, then you're back where you started. You're actually right. Put it back to the front. Well, okay. If I put it here and I put it here, well, then now I have x plus 5 times the log of 2 equals x minus 2 times the log of 3. These are numbers on your calculator, yes? And since I used a base of 10, I don't have to do change of base. Well, what's log 2? 0.031.
0.0. Oh. So.
What's log 3? Can you solve it now? You should be able to. You could distribute. Yeah, distribute. 0.301x plus, what do you get? 1.505. 954. Now solve it. That's what I got. That's what I got too.
I got like 4.
All right, so I added the 0.954. I subtracted the 0.301x.
How does that divide that?
Right, so then I divided by 0.176. Well, think about really, so this is 2.5, so that's like close to 5/2, right? 0.17, that's close to what? Close to a fifth? A fifth is 0.2. We'll just say, even if it's a fifth, so if I divide it by 5, by fifth, well then that's like 5/2 times 5/1, which would be 25/2, 12.5, right? You see what I'm saying? It's because you're dividing by a fraction, so you multiply by reciprocal. Another, or are you good? Want me to shut up?
Yeah, we're probably.
Good?